I thought then. Elijah, can you factor this one for me, please, for the x-intercepts? Oh, okay. To make things easier, this is what I was trying to say before. I'm going to do that just to make the algebra easier. So, Brendan, I'm going to multiply negative 12 and add to 1. What are those two numbers, please? 4, negative 3. Okay, so that's 2x squared plus 4x minus 3x minus 6 equals 0. If you're saying to yourself, I don't know what's happening, that's okay. Use the quadratic. No, it's not. If you do, you can factor in a different way. As long as you get your same final answer, that's fine. Okay. Then what I'm just going to do is I'm going to split it down the middle and take out a common factor. Hide that, I guess. 2x bracket x plus 2 minus 3 bracket x plus 2 equals 0, and then x plus 2. 2x minus 3, 0.
Negative 2? Oh, no. Yeah, it's negative 2 from.
No, I've just looked everything over, that's what I did.
Oh,
right, so I made it equal 0. It'll give you the same roots the same way. Okay, starting to come back. Yes, never left. Okay, so those, I put the comma 0 thing there because those are going to actually be the roots. So you'll need actually to graph those. Okay. All right, Rebecca, do you recall how to find the y-intercept of a parabola? Yeah. Yeah. Okay. So to get the y-intercept, you're just going to set x equals 0, right? So y is going to be negative 2 times 0 squared minus 0 plus 6. So y equals 6. So the point is 0.6. Okay. Do you want to be next? Yes. Okay. Now, so those two things are no big deal. I'm going to do the vertex my way. After today, you'll probably never find the vertex. Actually, not after today. After this unit, you'll never find the vertex again. Okay, but I just want to show you like you're back into advanced functions. So to get the x, it's just going to be, I'm going to do like the midpoint of the roots. Where I get the negative b over 2a from is that looks like the quadratic formula, right? Negative b plus or minus, and then that part's gone, right? So it's just going to be that part of the quadratic formula. So the b here should be negative 1. So it's negative 1 all over 2 times negative 2. It should be 1 over negative 4. It's negative 1/4. That is so easy. Completely square sucks. Sneaky?
My brother taught me that when he was in your class, and Mr. Walter said you're not supposed to use it because it was proven differently or something. Because it was like it derives from the quadratic formula. That's where the negative b's from, but apparently there was some errors because there's some that you can't use that for. That's what he said.
For the quadratic equations, the x value would be halfway between the x-intercept.
Right. I think maybe the thing is, unless there's no roots, that would be the only way, right? If there'd be no roots, you couldn't find the vertex there, right? But as long as there's roots, and we've shown you that there are roots, right? So that's fine, right? But because yeah, I guess technically you're right. If the graph looked like this, right? There's no roots, which is fine. Well then, yeah, that's not going to be the proper thing, but. Okay, but yeah, you should complete the square when you're in grade 10, definitely, and grade 11. You should always. So if you have younger brothers and sisters, tell them to complete the squares. Y equals f of negative 1/4. Okay, this where things get a slight bit trickier. Negative 2 times negative 1/4 squared negative 1/4 plus 6. Where's you at? 29 over 8. Okay. I'll work it out just to make sure so people know what's happening there. Okay. So this should be negative 1/8. Is that right? 49 over 8? Positive 49 over 8. Okay. So So my vertex then would be, oh, I'm running out of room here. What is that? -1/4 and 49/8. Now, I'd like you to keep it as a fraction as long as you can. When you graph that, you're probably not going to graph 8s and have your graph paper this big, right? So you can change it to a decimal when you actually graph it for this, but you should use the fractions always for your algebra and all that stuff. This coming back? Okay. Yeah. All right. Let's get this graphed up again. So you can do this on the bottom part of your, if there's questions, sorry, I know I'm going too quickly here, but this is grade 10 and grade 11, right? Maybe that vertex thing is new. If you want to complete the square, go ahead. I'm not going to stop you, but this is a lot faster. This is mainly coming back for most people. If it's not, please ask. Like, I know I'm going through here quickly because I only talk in one speed, and that's 100 miles an hour. So if there's something that's not clear, please ask. It just means that I'm not explaining it clearly. Amy, good? You're not good. Amy, are you good? You're not good? I'll make it here. So remember -2 and 3/2. So I'm going to graph this up here right now. It should be like horrible flashbacks to grade 11 for you guys, I think, isn't it?
Got into this course, people wish they were
You're supposed to be like positive, Mr. Positivity here.
Oh, you're going good to call back.
Oh, okay, okay, you're right. All right, I'll be the good cop today then. Everything's warm and fuzzy, okay? I have a ruler and everything, and it still isn't straight. Is it better now? There we go. So we need. Where am I going here? -2. All right. So there's 0, 1, 2, 3, -1, -2, -3. I get up to 6, 1, 2, 3, 4, 6. There's my y. Okay, there's my x. Okay, my points are going to be 0 and 6, which is up here someplace. 1/4 and 49/8 is going to be just a smidge above that. And -2 and 3/2. So -2 is here, and 3/2 is here. Yeah.
Yeah, vertex should be on this.
Better now? That make more sense? Good, thank you. Now, tell me 2 reasons before I do this that is a proper vertex. I'm going all the way back to grade 10 here. Amy, tell me 2 reasons why that vertex is proper. Start with 1 reason. Well, give me 1 reason that vertex is proper. Oh, goodness. Okay, go. Open downwards, that's one thing. It's downwards, okay. So what else do you know if it's open and downwards? What does the vertex have to be? Highest point, top, highest point. Thank you, good. Okay, I heard somebody whispered there, it's probably the middle of the roots too, okay? So we figured it's in the middle of the roots from right there. All right, domain and range for this lovely graph. Joe, I'm picking on you. What's my domain, please? What's my range, please? Go on, Joe. No. You said 6.125, which is technically correct, but I wanted it to go for 8. Why, okay, this should all be coming back. Oh, I'm just going so slow today. Okay, Mike, we may not have time for your example today. You may have to do the warm tomorrow, okay? Because I'm doing a coordinate right now is what I'm doing next. Skipping right over cubic. Your homework on this, can I get rid of this page? Yes. Your homework on this is page, where are we now? Page 71, number 8, CBG. Okay, this is going to be polynomial functions of degree 3 or more. Okay, in order to sketch this, as of in advance functions, we needed, how could you sketch something a cubic or a quartic or a quintic in advance functions? Right? No, you can factor too, okay, so roots we need. So sketching, I would need the roots would be first. How else? There's one other point you want to go out of the roots. Intercepts. Now we're going to, I'm going to tell this story now before we forget. Before we don't write this down. This is typically how a cubic would look in grade advanced functions, right? You know what I'm trying to say. In calculus, this is how they will all look in cubic. They will all look like this. Why could you not deal with that in advanced functions? Well, why would that be hard to graph? Well, go ahead.
Because we're used to them being like roots.
Yeah.
And having only one.
There's only one root here, right? So the point is, in advanced functions, you could never be able to tell this point, which would be important. You'd never be able to tell that point, right? So this is what one of the things calculus can do. They can instantly find that like easy. That's super duper easy. Super duper easy. All right. So, what else we need? We're going to talk about end behavior. Okay, an odd function. Somebody tell me what an odd function is, please. Okay, up to you, Ashley. Katie, or up to you. What's an odd function, please? Go ahead.
Cisco curve has odd degree and has point symmetry. That's all I really know.
Oh, boy, I don't know what point symmetry. I'll leave that for right now. Go ahead. Odd degree. Go ahead. You're saying yes, but not really though. Just the leading one is all we care about, right? So like, let's say it's like x9 plus x8 plus x6 plus x4 plus x squared. There's a lot of evens in there, but it's still going to be odd.
The highest.
Right. So the leading degree is odd. Okay, so a positive odd function is going to look a lot like y equals x, which looks like this. Okay? That's what a positive odd function looks like. Okay? So if you, and what that says in English, if you don't understand math, it says as x goes to infinity, this way y is going to go to infinity. That's what it says. And how do they say it in advanced functions?
Approaches.
Approaches?
That's what we did.
They use that. That looks familiar to you guys? Okay. A negative odd function is the same thing, but opposite. Think of y equals x. Sorry, this should be, this is like y equals x. Y equals negative x. So as x approaches infinity, y approaches negative infinity. As x approaches negative infinity, y approaches infinity. I do this quick because we're running low on time here. For a positive even, think of that like y equals x squared. As x approaches infinity, y approaches infinity. As x approaches negative infinity, y approaches infinity. These figure teaching calculus will be better at rating infinity than not. Negative, even. This is all coming back to people, I hope. I don't hear anything, that's fine. Yeah, go ahead.
What's the meaning that x equals negative? Like the y equals
Oh,
negative?
sorry. So what these, the way I always thought them when I was a kid, right, is that even odd functions all look like y equals x, except for x cubed is going to be the same thing with more curves. Okay, so every odd function is going to look like x squared, except for x to the fourth just looks like this. So x squared looks like this, right? X to the fourth looks like this. Okay, x to the sixth looks like this. Right? Like they all have the same end behavior, just the stuff in the middle that changes. And the same thing with x is going to be, the end stuff works the same as x, but there's weirder stuff happens with no, that's what I meant. Oh, I want to get one example done, I hope it happens. We're gonna graph a coordinate right now. Oh, yeah. My recording's still on, so let's make you talk again. Oh, not even my mother's gonna watch this one.